This is the audio notes for the introduction to the acid-base unit, just dealing with general properties of acids and bases. Again, a lot of this is meant to be review from Chem 1, and quite frankly, it's not the type of stuff that you're typically going to be asked when it comes time for the AP exam. So if I show you what's on the first slide, again, acids are in a lot of foods, which can give it a sour taste. One of the things that we will be discussing a little bit more is how acids can conduct electricity. Think of the term battery acid. But really, why do they conduct electricity doesn't have to do with the acidic property as much as acids will be able to create ions in solution. Next, metals will react with an acid to make hydrogen gas. Acids are usually found in a liquid or the gaseous form. One of the things in Chem 1 we tried to show you is that when acids react with carbonates, they will make water, ionic compounds, and carbon dioxide. Lastly, the pH scale is something that we very briefly touch upon in Chem 1. We will go much more in detail starting next week with calculations dealing with pH. But below 7 on the pH scale at normal conditions would be considered to be an acid. I do mention on the end of this slide, however, that you can have acids in the negative values. As a matter of fact, the nitric acid that we used in the how much copper is in brass lab in Unit 1, when we added the brass and the nitric acid together underneath the fume hood, that was below -1 on the pH scale. Again, we'll be able to calculate that, though, in the coming class periods. As for bases, again, a lot of people don't consider bases to be dangerous, but they're every bit as dangerous as acids. They're just the opposite end of the pH scale, as I mentioned on the last bullet point here, where pH of 7 is neutral, and then it can go above pH 7. 14 is typically where the scale ends, but it can surpass 14 as well. Bases we usually find as a solid. However, when we work with them in the laboratory, we typically will dissolve them in water to make it a solution, so it would be in the liquid phase instead. Again, chalk is a carbonate base, which is usually as a solid, but sodium hydroxide, very common base found as a solution. Solutions are slippery to the touch. So if you get it between your fingers, they feel kind of slippery. A lot of cleaning products have bases in them. If you've ever seen the movie Fight Club, they will react with oils to form soap. And not only is that interesting about it, but if you watch that movie, one of the initiations that they do is they'll put a solid substance on someone's hand and then they'll pour water on it. They're putting the solid sodium hydroxide, or common name lye, on the hand. Then by adding water, they turn it into a solution and they're giving people a chemical burn. Just like acids, bases have ions in solution, so they conduct electricity as well. And once again, I started off the slide by mentioning the information about the pH scale. That bases are the opposite end of the pH scale. In Chem 1, we did show the combination of an acid and a base. When you combine the two, you're trying to neutralize them, which is what sometimes it's called a neutralization reaction. Again, we did do titrations at the very beginning of the year with acid-base, although we've done redox titrations as well. We will be coming back to doing some acid-base titrations in this unit as well. In order to neutralize, the acid ions and the base ions need to be in the same ratio. Now, I have to be careful when I say that term neutralize, because one of the things that we're going to be learning through the course of this unit is that not all acids are created equal. Same could be said for bases. There are varying strengths of them. The third bullet point gives the most common acid-base reaction between the strong acid, hydrochloric acid, and the strong base, sodium hydroxide. So when an acid and a base of equal strength are combined, they can neutralize as long as they're in the correct molar ratio. And you see in that third bullet point, the sodium chloride is the ionic compound and water is created, which is what I'm mentioning on the fourth bullet point. We always have an ionic compound in water. If, however, carbonate is the base, carbonate will also make CO2, or it'll make bubbles when that reaction occurs. We've already gone over in the past how acids and bases make hydronium hydroxide, but I'll quickly remind you of that as well. That if you take an acid like HCl and you put it in water, this hydrogen will get donated to the water to make the hydronium ion. And there's your ions in solution. NaOH, an ionic compound, when placed in water, will break up into its parts like ionic compounds do, creating hydroxide. Again, what we went over in Unit 1 was the two definitions of an acid so far. Creates hydronium ion, that works there, and is a proton donator. This is H plus being donated to the water. A base, on the other hand, is something that creates hydroxide in solution or can accept a proton, which OH minus can very easily accept an H plus. And that is the introductory notes for acids and bases.